at once.
There you go.
And I have no idea what the volume's at right now.
That's fine.
Why?
This one's for headphone output. The actual one is back here.
The pattern, yeah. Based on the okay.
Well, there's the gain one on top of it.
Oh, what happens? It won't let you start it up. From the suspended. It just says no. Oh, wait, okay. So let's play the game. Guess which shell it is? Which shell? It's not the Alias one. Just start. Well, the process of elimination start. Start to say what the shells. I'm pretty. Try the emails.
Yeah, it was it was like such like a negatively just uncomfortable thing. You didn't see the.
We'll do announcements later. We'll do the halfway point.
He wasn't even like on a project again.
So Nick, we're gonna do announcements at the halfway point, so you can get started whenever you want.
We're gonna do what at the halfway?
Announcements at the halfway point.
What announcements?
The sign up for the mock announcements.
We shall not
Okay.
speak in the cam. Like it's like that's what they're telling.
Perfect. Okay.
How's that big traffic system?
Okay, guys, we are gonna get started for the Windows side.
Okay, we're gonna get started for the Windows side. Alrighty, yeah, I just got back from Suricon. It was an absolutely amazing conference if you're into like Suricata and using the Silk Stack to like find stuff. They run into a lot of really cool people, like all the Suricata core devs and like the people that are maintaining and developing the Silk Stack. There's a Wireshark developer there that like had been there for 10 years, and like the people who founded Emerging Threats, like a rule set for Suricata, and I got to go to a bunch of trainings and stuff for free, and it was really cool. So yeah, I'll probably in the future be kind of making an advanced session for using the Silk Stack. Hopefully in the next 2-3 weeks or so I'll have something set up. So yeah, I guess we competed in Hivestorm. Congratulations to Team 3. I guess only one of them is here right now.
Yeah, I think so. Let's see here.
Nice. Kind of showed us up a little bit. Got like 3 places higher than we did. Nice job. So yeah. What?
Gotta harden your system properly, Nick.
Right.
This Cowboy CCD CIT.
Okay, so yeah, anyways, here we're gonna get started in this Windows persistent stuff. Basically, I'll probably be talking for like 5 minutes, and then we'll get right into the lab for those of you interested in that side. Kind of this deal, like I showed this slide earlier. Basically, an attacker's gonna exploit your system. They're gonna drop a whole bunch of payloads, and then like these payloads, they're gonna try get these payloads to like run a lot. That's basically what persistence is they want to persist on your system. And there's a number of ways to do that on Windows, and that's kind of what we're going to go over here. So we got a few of the forms is auto runs via the registry, the Windows startup folder, creating services like malign services and things like that will do it. WMI persistence, DLL hijacking, and yeah, so. The auto runs registry persistence, like there's a few different reg keys they'll use here. Basically what HKey current user is if they have like user level access, like if they're operating as like a user, they can take this registry key and basically make it run that persistence binary, or run that binary whenever the user logs onto the system or something like that. And then like the run once key, just as it sounds, it's going to be deleted right after it runs. And then HKey local machine, this is a little bit different. They have to be running as the system level, at the system level. There's a few different things they can do there. They can put it in the current version, or the HKLM, software Microsoft Windows current version run once. Or the Windows NT current version win logon. So like basically whenever someone logs onto a computer, it's just gonna boot up, and yeah, so those are a few of the things. Scheduled tasks. The attacker places a payload in a folder such as the temp folder, or like app data, roaming, something like that. Or if they have enough access, they can put it in the Windows System32 folder. There's a lot of places they can hide their binaries at. Yeah, so it's going to be set up basically with scheduled tasks. They're going to be set off with like some sort of trigger, like it's going to be set off after 10 minutes or whenever a user logs on, or there's so many different things so many different triggers you can do to set off the persistence binary. And services, attackers can generate services and set flags. Like, for example, like on a service, they can set a flag like not stoppable. So when you try to go into the program or into the services console, you can try shut it down and it's not going to work. So you basically just have to delete it or something like that and kill it. But like, hopefully they're not smart enough to set those flags, but never know. WMI, Windows Management Instruction. Basically, this one's just it's Windows uses it to manage a whole bunch of services and things like that. Typically, like from my understanding, like a lot of Empire modules and stuff are going to heavily use the WMI persistence tactic. And there's to defend against this, there's the auto runs suite of sysinternals. You can do a few things and kind of dive down in there and find out if they're doing WMI persistence. Yeah, like I said, it can run to a lot of these attacks can just purely run in memory, and it's going to be very difficult for like Windows Defender, Komodo Kill Switch, or something to actually find it. And it can be triggered like by an event. Like if a user fails to log on, it's going to trigger an event. It's going to make that binary or the PowerShell script or whatever they have. It's going to start running, and it's kind of how that works a little bit. DLL hijacking. Basically, they take a legitimate DLL, they put it onto whatever they're using to modify the DLL, throw it back onto your computer, and it's going to look just like it's going to have the same functionality as the old DLL, but it's going to have like their payload. It's going to be in that DLL, and it's going to be able to call back to the attacker. Typically, they're going to have to be running as system for that to work. And yeah, so kind of dive into the lab here. I didn't get too crazy with this. Basically, let's see here. I only established like 3 methods of those persistence because I started at like 10 a.m. and didn't like get too far into it. So before you like get onto it, oh crap, I actually started it. So you're gonna want to start up your Kali Linux box first if you want this to work super good. It should still work pretty well if you did manage to do that, if you just turned it on. Password root, or user root, password tor, kind of the standard deal here. There we go. And as soon as you open your terminal, there should be an RC script or a resource script. Luke, do you know if I can just like run this script without having to do MSF console and then run into the script?
Oh boy.
Okay, never mind. Let's try this. So yeah, just open up your Metasploit MSF console if you can't read that. Yeah, there we go. And we're just going to type in one command here. It's going to be resource. Let's see here. What do we got? Okay. Windows interpreter stage / reverse TCP -443 -exe.rc. Basically, this is just going to set up a handler on our Kali machine so we can like see so we can like wait for our persistence binaries to call back to us, and we can kind of see whenever the binaries successfully come back to the attacker. So I'm going to kind of zoom out here a little bit. Oh gosh, what did I do? Well, let's just hope for the best. Am I in 4K right now? I think I'm in 4K and I can't actually see anything. Or not. There we go. So log on to DSU, password 1, bang. As it's logging on here, we should, if this all works correctly, we should start seeing a few shells come up on this. 1, 2, there might be a third one here in a little bit. But yeah, so you can kind of go into your your Windows 7 box and try to find out what the persistence methods are being used, try to find the binaries. I left Komodo kill switch on the desktop, so you can kind of use the auto runs feature of that to kind of look through that and find the auto runs keys and things like that. And yeah, so like I said, there's only a few methods that are on this Windows box for you to kind of root out. There's the you schedule tasks, a few of the registry keys, and then the startup folder if you know where that is. So yeah, basically just find that and kill the persistence that's on the box. Then I'll kind of just be up here. So, I basically forgot everything I did, so I'll just kind of go through this a little bit too. But it's like you can start with auto runs. You go to hijack cleaner, see if there's anything there, or you can start kill switch and see what process is running and things, and try kill it from that way. But if you use the kill switch method, like if we go like this, kill switch, run as administrator, and we find the process, it's just going to come back up because all you're doing is killing the process, and it's just going to start back up here in a little bit if you kill it. So. Oftentimes they're going to be using like Empire modules and stuff, so that you'll see like PowerShell up here rather than like an actual binary or exe binary. So go to that, kill the process tree, and theoretically, oopsie, it closed. But it's probably going to come back up here in a little bit. I'm not sure what the trigger for that was. And typically the red team, they're going to utilize like just multiple variations of whatever persistence they have available to them, so you can like expect a lot more than what's on this box for sure. But for this auto runs analyzer, you can go view, you can hide trusted entries, and then it'll like basically erase all the stuff that's well, it should have erased all the stuff that's from the Microsoft Corporation or as you can see, like, hey, there's this logon guy up here. Go find that. It's called the WinMal, so that's obviously not a legitimate process. Jump to entry, and there it is. go ahead and delete that thing. And then we can also see that they dropped the binary in the app data / local winmal.exe folder as well. Okay. Find the binary, go ahead and delete that thing so it can't be run again if they... Well, I guess we can't delete it. Let's try. Oh my gosh. Oh, basically that means that the process must still be running, so you have to go find it and kill it. So theoretically, we should be able to delete that guy now. There we go. So remove that method of persistence from the startup folder. Then previously we destroyed a registry key. Let's check the scheduled tasks thing. And it looks like there's another one. Let's jump to entry and see what that's all about. Let's go to the task schedule library. You see something called malware. We can kind of see what they're doing here. Basically, it says it's just going to run every 10 minutes after the initial trigger, which was, I don't know, I think the initial trigger was basically right when it got on the system. And then they threw that in the app data local winmal.exe folder. So if we go back to that, delete that guy. The scheduled task is basically worthless, but we can go ahead and still delete the scheduled task because it's obviously not legitimate. Oh no, that's not good. Well, basically, as you can see, all of our persistence binaries our interpreter sessions to the attacker machine were killed, so that was kind of our end goal there. Let's just make sure there's nothing still calling back to us. Yeah, so I think we probably, hopefully, killed all the persistence that they had in on our machine. Our red team has a lot more complicated persistence than what we had today. Like they use like WMI persistence from what I've seen, and they utilize scheduled tasks. They do utilize the registry keys, and I do believe there is one of the red teamers does do a lot of stuff with DL hijacking. So yeah, be on the lookout for that as well. Yeah. So to recap, today we just tried a scheduled task, and we deleted a register key that spawned a persistence binary every few minutes, and then we killed a binary that was in the startup folder. So yeah, that's basically Windows persistence and stuff. So that's all I have for you guys.
Okay, just a short little bit of announcements. A reminder, we're going to have the long form mock starting next week, Tuesday. You're going to have 3 weeks of prep time with your environment in order to secure it. And then we'll have the actual competition, I think, early in December. So yeah, just another reminder, sign up for this if you're interested in blue teaming. It'll be fairly similar to CCDC mocks, but a little bit more software auditing and that sort of thing. So sign up for that if you haven't already. And then the CCDC, the second CCDC mock will be held in a couple, 2 or 3 weeks from now. And we'll have a sign up link out for that tomorrow. So keep an eye out in Slack for that. And I think I posted yeah. So yeah, the link for this sign up is in Slack as well. So yeah, we'll start Linux at 6:25.
Yeah, that's a beautiful, interesting side effect of what we kind of decided to do is that now we have a lot of open space that just exists because I told everyone else that we're starting Linux at 6:25, so we theoretically have time now. That just exists. So if people want to do stuff, that's fine. I'm gonna continue to attempt to deploy out VApps that have broken because they have. But I don't know. That's just an interesting side effect. Keep that in mind. We will be doing for Linux side. We have the DefSec Linux Persistence VApp. So assuming you're sticking around, make sure to get that set up and deployed, or not deployed. That's my job. Powered on and verify that you have it. If you don't have it, this would be a good time to go grab it or tell me, and I can try to get it set up for you. So the question is, Nick, should we go all the way to 625? I think we got it, don't we? We have to. We don't have a choice. So, if anyone does not have the VApp, this is a good 20 minutes to tell me you don't have the VApp and let me help you with that. Peter, you want to come up here? This is kind of interesting because Peter made it, and then we went and we changed it a lot, and then we're like, Peter, you good to go to present? I don't even know what you did. Well, it's so half your. This is the best description of what happened. We took your stuff with the initial plan of taking it and then just tying it into the scoring engine. And we took your stuff, modified half of it, broke the VApps 3 times in a row. So half of it is still there, modified, and the other half is gone, replaced with other things. So this is now a good scenario of it's not just demonstrate how to find the things, you also don't know where half of them are. You also don't know where Got it. Well, we'll hear around too. It should be pretty, laid back.
I just got off work, so I don't have a lot of chance to look at stuff.
Well, you have time because there is a 25-minute gap that exists now because of I wouldn't say it's poor planning. I feel like this is still a good decision, but our interesting planning.
Cool. Just gotta make sure Windows takes
So blame Nick for not making Windows take longer. That's what I'm hearing.
I'm sorry. I just wanted it to go a lot shorter than it usually.
I don't know. Well,
Trying to be efficient.
you ruined everything.
Oh, right, we should talk about advanced lines.
Oh, yeah, so we will be doing, we had advanced sessions last week, and we did advanced Linux, and that I think went well. I think people appreciated that. We will do it again this week, and it will be a continuation of what we did last week. Sorry, Windows folks. I don't have things for you at the moment.
Yeah, if Windows people want advanced Windows, bug Andrew and
That would be a good start. We should probably do some advanced networking afterward, but I didn't schedule people in, and I will not be here at that session. So Nick will be running it as he normally, well, I mean, as he did last time too. So, but I think that was a good session last time. I think we made some good progress. So we'll be continuing that. Ideally, the time after will be either networking or Windows to get some variety in there. Because I'm sure Nick would love to talk about Suricata if nothing else.
Oh yeah.
Would,
We have a few sessions about that.
Well, that could be the next one after then, unless you want to do something more unless somebody wants to do something more Windows based. That could be a good one. So
someone has a question whether they'll be able to catch up if they missed last week's advanced session.
it's on the well. Okay. Yes, and you don't need to, but yes. So the last time we basically went over PDSH stuff, which we actually made some interesting progress. Like people made scripts. That's basically what we did during that period of time. And it went pretty okay. Next time we're also, I think, basically making scripts, but we're going to be doing it using a different framework. We're using Fabric is probably the idea for the next one. Or you do want to continue on to, Nick?
We could do Fabric. I think actually like codifying what we do with PDSH might be a good idea.
Okay, so it'll be a mix of some. So yeah, if you want to catch up, the video does exist. I just realized, what happens when I don't... it's just a black screen and talking, right? That's what happened. That's 1 second here. That's what the stream... Okay, I just wanted to verify what the stream looks like. Oof. I don't have a 9K.
YouTube.
Nope, I can do this.
YouTube.
No, I'm not going to do a video that has sound. How does it actually work, though? Because we don't transmit sound over HDMI, so it's just this, right?
Yep, I think so.
Okay, just want to confirm that. So this is doable then.
I think they would hear your HDMI.
Oh, I thought you just okay.
This room would not.
That's what I was trying to that's what I was questioning.
So this room won't hear the HDMI.
No, they won't. So I better.
So if you have a terminal going ding ding ding, then it's going to be really annoying.
that's
for everybody
actually
watching the stream.
true. Have we ever had that before? Has anybody noticed that?
No.
You're sure we've never done that? In all 40 videos we put out, nobody had like a terminal that was just spamming sound that nobody was listening to.
I have never noticed it.
We're good timers.
Lies. You're welcome. You're welcome. I mean, we could, if we want to adjust session times, we can. That's perfectly doable to a degree. So I guess that's probably what we can do in the future is, yes, Nick, no, Nick?
How is that? That's not going to be possible.
Well, it should be the same time frame. It's not the same as like switching them around, right? It's just the same. Well, I guess you're right. Oh no! Stop! I don't want to hear my voice. It's terrible.
I think that was me.
Was that yours?
I mean, it sounded pathetic, so I'm guessing.
No, it was me. I sound pathetic apparently in real
Okay,
life.
we both do then. I mean, every time we hear my voice, I cringe, but I'm pretty sure that's everybody.
What, Cody? Are you not appreciating this? This,
I'm doing YouTube for just 2 seconds.
this is some beautiful. I was just saying, are you not appreciating our conversation here? No. Okay, well, that's fair.
So we're basically just waiting in case people show up for Linux.
That is the hope.
right?
I think it's a hope in vain, but we will find out.
Cool. Because, I mean, I've got a presentation ready to go if we want to do that. It's just going over the, like...
I think we've committed at this
basic
point,
stuff.
Peter, haven't we? Nick,
Committed to waiting?
Well, so the issue is if someone feels like someone shows up during the 25-minute, like at that time, like we
just-
told them it would be that time, so I feel really bad.
Let's just send a message in Slack saying, hey, is anybody else planning on showing up?
If you're not here yet, then get here.
If you're not here yet, then click what?
If you're not here yet, then get here.
Do it, Chase. You're an officer now. What, Cody? Exactly.
Did I say something?
No, you just make faces at me, and I'm like wondering what you're thinking. So
Here, I'm sending a message.
I got it, Peter.
Oh, never mind. I'm not sending a message. I'm gonna
I mean,
unsend that
it's not like
message.
we have permissions on Slack. Anybody can do it. I don't care. In this case.
Cool, Chase can send a message to
Well, no, it's not that Chase can send a message. It's that Chase can take responsibility for his actions.
It's not that Chase can send a message? He can't send a message?
Well, I mean, he can send a message, but you can also send a message. But if you send it, then
Okay, sounds good.
we'll just, I don't know. I don't know. It's easier to blame Chase for things. I don't know.
All right. I mean, we can still do stuff, even if it's not
We can.
exactly what's on the schedule.
What do you want to do?
I don't know.
Have an advanced session? Should we go over what we did in advanced Linux? That might actually not be a bad
Do it.
idea.
That's a good idea.
That's actually pretty dang good.
Preview.
Oh, I gotta. The issue is now I have to find things. Oh, you do. You do have it. You do have it. Okay, that would actually be perfect. No, why am I doing this? I just need Slack, guys. I've lost all my things. I just have like 17 windows open on one thing, and it should be. Well, so I think it's actually not an issue because I should be muted most of the time anyway. Oh no, I went past it. Advanced. Oh, it's because you threaded it. There we go. Right there. Okay. We just want to go over what we. Yeah. We'll look at your slides briefly. We'll look at both. Just kind of get some background information. I got time, right? I got time. So. Present. Put this in present mode. Okay. So, on the Linux side, and this is a problem for Windows 2 to a degree, we have a lot of boxes. If you guys went to the first mock competition, it might not have seemed like that. You guys probably had one box per person, so you might be thinking to yourself, oh, that's like one box per person. That's not that bad. We can probably do that and do Index at the same time. The issue is that this scales up for our CCDC style mocks because at Nationals, we don't have like 8 boxes for 8 people. We have like 27 boxes for 8 people. So it definitely scales up to a point where we're looking at 3 to 4 boxes per person. And then if you remember, your network firewall guy, he normally just focuses on the network firewall. And your inject handler, ideally, it can be doing other things, but maybe they should be focused on managing injects or so on. You have different positions doing different things. So when you get down to it, maybe you don't have 8 people for 27 boxes. You have more like 6 people for 26 boxes, which is a harder ratio of like 4 to 5 boxes per person. So the whole point of what this session was, oh guys, my battery's running low, was basically to say, oh, thanks, Power. Really appreciate that. That we have to do the same exact thing on each of our 5 boxes, right? Each person has to do exactly the same thing on each of our 5 boxes. But instead of doing that, how about we come up with a way to do that in parallel? How about we take this Linux checklist right here and we use some other tools and we have one person secure like, let's say 10 boxes at a time. Because they're basically running the same thing. They're running the same Linux checklist on every single box. So that was kind of what that session was to explore. It wasn't a lecture. It was just us sitting down, looking at some possible things, and then start messing around with scripts. So we had a lot. We had a set of requirements. We had the 2 tools we wanted to go over. We really just focused on PDSH for the most part because that's what we jumped on first. So we basically said, here's a tool. Let's try to figure out how this works, and let's try to use it to do things that we want to do in that scenario. So we kind of had some, a baseline. And here's what people actually ended up coming up with, which I don't, oh no. Yeah, that's better. Which was some really basic, it seems basic, but you believe it or not, it takes some effort because of some particular functions that people have built into these things to not make them work for us. I'm sure that's the exact reason they did it. So what PDSH actually does is PDSH stands for parallel shell. All it does is executes whatever it's given in parallel. So in this case, we're just executing everything after this point in parallel. Once again, people who were there, and Nick can correct me if I'm wrong. So as far as I'm aware, that's all it does is executes this. What SSH pass does is essentially allows us to send a password, this one right here, to SSH. In this case, we send it to SSH copy ID, which is just a wrapper that lives around SSH and does the copy ID function, which what that does is moves SSH keys to boxes. So what this entire thing does in parallel is it copies your SSH key on your system to other systems. Now, what does that let us do? We have an SSH key in our system. We've given it to other people. What that lets us do is remote into those systems using that key. So that means we don't need a password anymore. We use the key. The reason we have to do that is because there's not really a good way to say we have 10 systems. Each one of them has their own unique password, because now we have a list of 10 systems with 10 usernames with 10 passwords. PDSH is not set up to work like that, so we basically have to use keys for that. So that's all the first one does. We copy the keys over. Now we can SSH into them normally or with PDSH, no password required. This next one, basically same kind of concept, uses PDSH to exec, uses SSH pass to password, but then we're using SCP, which is to transfer files. So now we can transfer files from my system to 10 other systems. We just say, and depending on how we do that, is that backwards, Nick? Is that from theirs to, that looks like theirs to ours. That's reverse. So in that one, we take a file from all their systems, we pull it in. The idea with these kind of scripts is that we can take a password change script, we can write it out nicely, and then we can push it out to 10 systems. And then we can run it on those 10 systems. And now those 10 systems have passwords, all their passwords changed, and they'll export, ideally, a CSV file, and then we'll pull that CSV file back in. And then we submit password change requests for 10 systems. Ideally, this could be done a little bit slower than you would secure one system. So not 10 times as fast, but maybe 6 or 7 times as fast. Ideally, is what we're looking for a speed factor here. The whole point of this is to get the basics done really fast so you guys can hunt for persistence and you can do injects and you can do other things against red team that's not just, fall behind red team and just try to secure passwords and do basics when red team's already in your system and they're having, they're doing stuff. And then I think Nick was working on, is this you, Nick, right here?
Yeah.
And then I think Galen actually came up with most of this once we got started. So thanks, Galen, for showing up. Thanks for helping out. And that's kind of the point is this isn't for us to, in the advanced sessions, we're not trying to have a lecture and, tell you things. We're looking for, this is our problem. This is something we want to figure out. And it's more of an exploration of you guys, maybe we'll give you a tool or something and we can explore it as a group and try to figure out stuff and, make things happen. So I didn't write this. Nick didn't write this. This was actually mostly Galen when you get down to it. And I think, Nick, you were doing that script right there.
Yep.
Oh, gosh. I got to make sense of that. Okay, password equals TRDC. So you're generating random for your password. You get the user out of the password file. Does this work?
Yes.
Okay.
If you're on Linux.
What does it gracefully fail if I'm not?
No. Well, yes. It'll gracefully fail, but it'll make it look like it succeeded. So,
Oh,
something we were
that's
working
not
on. We
good.
didn't finish this.
Okay. So the whole point of this is the idea of the password change script, except it generates random passwords. Instead of, like when you make a password change script, you're like, I want the passwords for every user account to be, normally the traditional ones, but fish are hot. Is that not incorrect? I might be talking to the wrong people of that. That's Chris Liu. No, was that Chris or somebody? That was Kyle.
No,
That was Tim.
Was that Tim? Oh, okay. Yeah, you guys' passwords are quite amusing at competitions. We really appreciate them. We don't. That's a lie. But whatever. Make strong passwords. They should all be easy to type in alphanumeric. But the whole point of this script is it generates random passwords. It can be run. Ideally, it gracefully catches to see whether you're on the right system because here's an example. When you guys are at competitions, you don't get 9 Debian 8 systems. You get a Red Hat system and a FreeBSD and a Fedora and a Solaris and a wide variety. You don't get, they're not all Windows 10. They're Windows 2016 server, they're Windows 2012, and so on. You get a variety of systems. So ideally, when you're making these scripts that you want to be parallel, they need to be able to run on a wider variety of systems than you're normally accustomed to. Granted, on Windows, if we ever have a session for that, it's probably going to be a little more like PowerShell remoting and, I don't know, PSExec maybe. I don't know if anybody has some good idea. You've Cody, do you know very much about PowerShell remoting, Cody, or Nick, or Reps? Do you? I'm just asking because I thought it was enabled by default in 2012 and up.
I don't think it's enabled by default.
It's not? I could have
Domain, I think it will.
on a domain.
For servers.
Okay, that's what I was asking.
Yeah, you have to enable it. You have to enable it with like a commandlet.
Okay, but it will be enabled on server 2012 if they're joined to the DC.
I don't know if it's enabled by default. It's optional to enable.
Okay.
Like, they use the PS exec internal blue exploit. There's a lot of PS exec stuff that drops.
PS exec. So I think the issue we overhead. So PS exec, if you guys don't know, uses SMB to execute commands. Is that a good description?
Yeah.
The issue with isn't the issue we have PS exec in the past is that it's kind of buggy, I guess, to say it lightly. I don't know. I thought
Ask Brianne, she was using it all the time last.
I thought we had issues with PS exec where it would sometimes fail, which was unfortunate.
Hey Ryan, how was PS exec?
How was the PS exec for you?
The first one.
Yeah.
So basically, I used it the whole time, and I would go in, I'd add users, and I don't know what they were doing. I think they were purposely changing the passwords on the users just to like annoy me, but then never changed default creds. So I just kept getting in the same default creds over and over and over again when they killed my shell.
Did you have any issues with PS exec randomly failing when the ports appeared to be open?
Not really.
Okay.
I mean, maybe the
good to
shells
know.
just randomly died because of that, but I think it was because they were changing the passwords on me because they wanted to be annoying.
Should that close your existing session though?
Well, so basically what would happen is
I guess
they
you're
would close,
okay.
So the shell would
Yeah,
die,
'cause PS
the
exec
session
doesn't-
would die. I'd go back in and try and use the same creds that I started with. Like if I created a DSU account, I used the password that I created the DSU, and then it wouldn't work. So that's what I thought was going on.
Okay, let's do it.
Cool. Ready for
I'll
that?
feel bad for every person who walks in late, but let's do it.
I won't feel bad.
Oh wow. I know we did.
Did you?
Peter put a message in chat.
What? No, Chase said 6:15. I thought you guys said 6:15. Initially, you said 6:15ish.
Yeah, I heard 6:15. That's why I put that in chat.
Did I
Def
10
sec.
minutes early. But are we going
Oh yeah, that's right. You did say 6:25.
Oh, is it not 6:15? What?
Yeah. Sorry. Windows was supposed to end at 6:15 and like whatever. Doesn't matter. Nobody's
It
showing.
was.
If they do show up, whatever.
Technically, they're supposed to be here. Well,
All right, cool. So we have kind of a really fun little lab deal this time. It's not going to be just me talking and you guys following along. It's going to be we have a scoreboard up for you to that's scoring the persistence things that are there that you have to try to get rid of. So I'm going to go over kind of the concepts behind it, but I'm not going to walk through how to like actually find all the individual ones, right? So these are the places that I thought kind of summarized for the most part. Feel free to shout out if you have other things that I'm missing. Were places that persistence was implanted on systems. So basically, the first one to look at is places where scripts run themselves. So these are things like cron, right, or services that are enabled, fun stuff like that. Currently running processes are processes that might start themselves up, right? Those might be a form of persistence, and it's another way to find them. Network connections, it's not much use having some sort of persistence on a system if you can't like actually use it. Most of the time those uses are going to be from a network, being able to remotely exploit the system. Users and groups, right? So this isn't really something that's super malicious and cool, but it's just they have a user on the system that they can access when they need to. Or they have a user that's in the wrong group and has more permissions than it needs to. Aliases, if someone's gotten on your system, there's a good chance that there's just an alias that's really annoying and it's doing stuff other than what it just does, or what it should just do with a regular command. File permissions, some commands might be set. So a regular user that should not have a lot of privilege can use those and gain privilege that way. And logs, right? Logs are really useful for a lot of fun stuff. Not as much fun to look at, but they're very, very helpful. Cool. So places where scripts run themselves. Shell RC files are often overlooked. This is like the bash RC. If you're using ZSH, it'd be your ZSH RC in your home directory. There's some system ones as well. They're usually stored in etc. Sometimes, I think depending, whoops, meant to highlight that, but I'm in a presentation, so that doesn't work. I think depending on the distribution, they're called sort of different things sometimes, but I might be wrong about that. Also, etc init.d. So this is just a folder in /etc called init.d. Before systemd was really a thing that took over, if you wanted a service to run or a process to run when a system started up, you would put a symlink to that process or like just a file there in etc init.d, and this system would be like, hey, I'm starting up, I'm going to run the stuff that's in this folder. etcrc.local, that's stuff that starts when the system starts, right? It's just if you want to have a command that runs every time that the system turns on, you'd throw it in etcrc.local. I forgot to put cron on here. etcrc.0, there are different things than just rc.local. rc.local is what we usually look at, but there are other ones as well. There are different run levels for Linux, or at least that used to be more the way that it was. Systemd has kind of replaced that too, but the RC directories kind of reflect the old system. So there's a folder called etcrc.0. That's stuff that runs when you do the power off command, right? Or shut down, right? So like while your system is shutting down or before it gets shut down, it will run the commands in there. So like that's how sometimes I think attackers can get some fun stuff to happen that makes your machine not turn back on. rc.6 is stuff that happens when you're rebooting, all sorts of different things. So like rc.5 would be if you're booting to a graphical interface. But if you're just using command line, then that wouldn't get run when your system turns on. Of course, there's cron. Should have put that in here. But every user has a cron tab if they're allowed to use it. And that can be edited, if you're that user, by typing cron tab -e, so cron tab edit. Otherwise, those cron tabs are stored on the system in var spool cron, sometimes cron tabs, depending on the distribution. And that's a really nice way to see, okay, which things have commands that'll run periodically. There's also a system cron tab in /etc cron tab, right? And there are other cron tabs in /etc cron.d, or at least there can be. So that's just a drop-in file. You can drop a cron tab in there, and then the system will look at it like every minute or so and say, okay, this file says to run this command at this time. I'm going to run it. So I'm not going to talk your guys' ears off about cron because I think most of you have some general understanding. So running processes and services. ps-aux shows processes, right? It's just a nice way of listing them. If you pipe it into less, then you can scroll through the list. You can see all the processes that are running, and this is going to be a lot of stuff, right? It's not always the easiest if you don't know what all the good processes are, or if something's just named something that's very similar to good process or the same as a good process is not the simplest way to find things. But looking at services, if you're using a system that has systemd, which will be most new things, systemctl list-unit-files will show you like the system files that are there, like for services or like targets or sockets and fun stuff like that. You can see which ones are running. You can see if any of them are out of place. And it automatically kind of puts itself in sort of a less like scrolling interface. So that's nice. Network connections. So is netstat officially deprecated?
Which one is?
Netstat?
It's not installed by default on newer Ubuntu distros. but
It's kind of just fading away, right?
I didn't know it was deprecated. I guess
I don't know if it is deprecated or not, but it isn't installed by default. Netstat, I mean, if you've ever done a TELUS class, you do netstat in Windows. Netstat in Linux has its own, like, very similar things. If you throw a whole alphabet soup of things, I always remember it nalpt, which is not a very good way of remembering it, but it works for me. You throw that on there, and it'll show you all the things that are currently like making network connections and listening, right? And you can set it up. There's a command called watch. If you type watch and then another command, as long as you're not redirecting output, it'll usually work. And then it'll just refresh every 2 seconds, right? It'll check, okay, 2 seconds have passed. Is there any different connection? It'll show you the updated list. It'll just run the command every 2 seconds and show you the output, which is nice. But for kind of like complicated stuff, that doesn't work the best because it's not always something that you're going to be able to see. It might send a single packet back every once in a while, maybe every 5 minutes. And even if you are watching NetStack very, very closely, it might not show up. And then there's LSOF, which is list open files. That's what it stands for, right? Okay. LSOF-NPI. Since everything in Linux is a file, right? Like network connections stuff is also sort of represented in files. And these -n capital PI shows like network connections and listening things, similar to the way that netstat does it. But LSOF is generally installed by default, if I'm not mistaken, and netstat generally isn't. You have to do like apt install net-tools is the package name. Users and groups, right? If someone gets in there, kind of the simplest way to maintain like persistence is users and groups, because you just add a user, and then you have another foothold to get back in, right? So if you have a list of users at the beginning of a competition, or you just like have a list of authorized users, and then you can compare which users are actually authorized. Oh my gosh, I feel so bad.
You should feel bad.
I feel bad.
I'm kidding. It doesn't matter for this one.
Sorry, we started a bit early, but that's
I
okay.
missed all that knowledge. Peter.
It's not a big of a deal in this one because it's mostly lab-based, so
Mm-hmm.
if you've missed any knowledge, it will be conveyed.
Mm-hmm. So users and groups, if someone malicious makes a user, they can log back in as that user. It's kind of simple. Commands to check users and groups, like you can do get ent pass wd is a way of getting like the users that are authorized to log in there. If you want to edit those, like assuming they're local users and not from some other source, you do vipw, which is like vi, the editor, pw, password, right? That's a way to kind of remember it. VIGR is the same sort of thing, but group is a way to edit Etsy group, and VIPW-S to edit Etsy shadow. Generally, don't just straight up edit these. There are tools meant to do this. For Hivestorm, we did a wonderful find and replace in Etsy shadow, and somehow that didn't brick everything, but it worked. So that's a way to like remove users from groups if you don't know the specific commands, but there are other commands for that. If you want to delete a user, the simplest way to do that is user del and then the username. It's just the word user, del, the username. They're gone, right? You don't have to worry about messing up your system or having inconsistencies between these three files, right? But generally, if you edit one of these, you have to edit the corresponding ones to make sure they work, right? Cool. So there's that. And then aliases. Aliases are a really, really simple way of just like being really annoying, right? So they're useful to make a command do more than what it just does. So for those of you familiar with Python, black is a cool tool that just goes through and reformats your Python, right? To make sure it's very consistent and good. But to make sure that I didn't like push changes to whatever repository I was working on without reformatting my code first, I aliased git to run black first and then run git, right? So that's a legitimate usage. But other people might do alias, cat, right? Would be start a netcat shell and then do the regular cat command, right? So you might not notice it if you're just running the command, but it's pretty simple to tell when something's alias if you just run the alias command. You just type alias, it'll show you all the aliases. If you want to remove an alias, you just do unalias, and then whatever it is, that's aliased. And then you have to do some hunting to try to figure out where that's getting the alias set, but that will generally be in one of these places where things can run themselves that we talked about earlier. Cool, and file permissions. There are a couple ways to do this. You could do like a recursive ls and grep for the permissions that you're looking for with like a regex, which is kind of weird, or you can just do the find command. Find command is really nice. I'll go here. I'll zoom into if I can figure out how. Yay. If you do man find, so man is manual pages, it'll just show you information about whatever command you're doing. And you search for, I'll scroll down a little bit. If you type / you can search through man pages or less or other of those things that are basically all using the same thing. So that's a handy dandy thing. If you search for perm, you'll find like file permissions, right? Where'd it go? Is it working? I think I need to zoom out. Hitting N will show you. So then you can see like, okay, I'm looking for things that are this specific file permission. If you keep going, it'll give you examples, if I'm not mistaken. But yeah, you can read through that if you want. Here. No, where did the thing that I was looking at go? Here we go. So here's like a to find SUIDs, right? You do this same sort of thing. Find slash means start looking at the root of the file system, so you look through all the files. Dash perm, right? You're looking for permissions, so that's what you're telling find to look for. And then whatever code it is that goes with it. So dash 4000 is what it goes with SUID. If you're doing dash perm 664, it'll tell you which files have read and write permissions for their owner and group, but other users can read and not write to, right? So man page for this is actually really, really nice and not too bad if you're willing to scroll a bit. And then Q is how to exit man pages. Whoops. And then logs. So if you're in a real fun competition, you're going to be able to set up something like Splunk or Logarithm. They're really, really, really cool tools. They basically just take logs of like all sorts of stuff that's happening on your system and aggregate them so you can search through them, which is neat. But the Logarithm is free and open source. Splunk like costs money if you're using it on more than just a handful of machines. Right, Cody?
Logarithm is not free and open source, and that's one of the super expensive ones.
Oh, dang. I was wrong.
Yeah.
I must have been thinking...
Verilog, yeah, and Elastic are here. Yes,
Okie doke.
exactly.
Cool. Well, thanks for correcting me there, because
Yeah.
I don't want anybody to end up with like a credit card bill because of me. Cool. And then if you're checking local logs, varlog secure is like for Red Hat-y stuff, and varlog messages are places to look. There are a lot of logs in /var/log, right? For applications, if your application isn't working correctly, that's a great place to start trying to troubleshoot it. Fun stuff like that. And that's basically everything that I have as far as just like general places to look for persistence. Is there a way to just make Google Slides just constantly circle through the slides?
I don't know. We'll probably be using it.
Okie doke.
Leave it up there for the moment.
Cool. So you all have a VApp. If you guys are ready to go, then start hunting, and then we'll be around if you need help.
I'll just show them quick.
Okay.
Scoring engine side, that's not-
Michael has a scoring engine side to show you.
Well, they have their own comments. I just want to make sure they knew generally what's going on. So at this point, I think Shane was not here for Windows. I think that's fine. That's fine, of course. But I'm calling you out. Yeah. If you were not here for that interim period, I was trying to make sure everybody has the VApp, hopefully. So, I guess that's a question. Does everybody have the VApp? Who doesn't have the VApp? Okay, I'm assuming everyone has the VApp and has attempted to power it on, and it has worked. If you've not, tell me in a second, and we can do that. Because I'm not really demoing anything. Oh, I opened the wrong one. That's the template. See, it's fun to find stuff, guys, when I have to do like this. No, that's not true. There's a more efficient way to do this. Okay, so in the VApp, there are 3 boxes. There's pfSense. It is a pfSense box. There is Ubuntu 16. That is the box that has persistence on it that I expect you to remove. And there is scoring. When you log into scoring first time, I don't know, does it have any credentials on it, Nick?
No.
It doesn't. You should be able to log right in, and then you might have to open up a web browser. It might auto open too. If you open it and it doesn't auto redirect you to localhost, go to localhost, and you'll see this page right here. And this is the scoring engine. So this is basically just a description of mostly the shells and a couple other vulnerable persistence sort of things that are on your system. Your goal is to make this all go red. Currently, it will start with shell 3 being red. And shell 3 might turn green. Who knows what's going to happen? That's just how it starts. So whatever triggers shell 3 has not yet been done on boot time. So the goal for you guys is to make the entire thing go red. IP tables has been removed. That is intentional. Your goal is to remove the persistence, not to firewall it off in this case.
And don't change passwords for anybody.
Don't change passwords.
'Cause that'll screw it.
Don't do anything that you normally do. Just find the persistence and remove it. So, hopefully using a couple, and I'll probably just scroll through some things quick here, but yeah, there's shells. Find them, destroy them. That's really the premise for this entire thing. But I'm not gonna, and there's multiple ways to do this. So you could, for example, if you guys just do like a PSOX and then like you find them and kill the process ID, that kills them and they'll go red. but the goal is for you to have the persistence destroyed. So once you're done destroying all the persistence, reboot the box and make sure you're still red. Because if it isn't, then you didn't do it right and you cheated in some way. Yes, Galen.
Are they doing the box and then have things where
They'll go red and then they'll go green again.
they're still red?
They're still red. Okay.
Can you pull it back up and you had 11 to shut off one of the
I mean, you could. I don't know why. I'm trying to think here. Have you logged in? Well, you got to. Okay, I'm trying to think here.
Is it goal to get them?
It might be on the scoring engine side. If you reboot the scoring box, it should.
Yeah, reboot. No, Nick. Actually, so that's actually true. Nick, there might be some minor issues with the scoring engine. So I guess reboot the entire VApp when you reboot the one box. Is that correct, Nick? That's an accurate assumption.
You could try that.
As Nick described it, the scoring engine does not deal well with failure in this case. So if it has a single fail check, it might stay down.
It's mostly hacked together.
This was unfortunately hacked together. Peter had stuff set up, and then we ruined his things. We ruined his
They started with Debbie and ended up.
that was attempting to fix a different issue. Ironically, I forgot to mention that. Yeah.
Play music over the HDMI there?
We'll find out.
They got it.
Well, no, but then it won't.
You have to mute the mic.
We will. What happens if I send audio output to this?
The easiest way
Yes.
is to open up a web browser on the Mac.
If I do it from there, will it go into the stream or will it actually like? Okay.
Which is better, so you don't get our channel taken down.
Cool.
Nick, give me your mixtape, please.
Just play the lo-fi beats that Andrew always does. It's on YouTube.
No, you got to do it on this
You
one.
can set
right
it to loop.
here. You got to do it on this one.
Yeah, I know, but
Okay.
you can set.
I don't
What do
feel.
you do?
Oh, you found it?
Yeah. So there's a setting. How advanced and played. Set it to
Yeah,
loop.
Galen.
It's still broken.
You reboot the scoring engine. That's interesting. That doesn't.
Cool. I'm gonna.
I'm trying to
have the
think here.
slides just
Are
looping
all
up
of them
here.
broken? His worked. Okay. Because there will be some that will be broken until you log in or until you execute certain functions that constitute retrieval.
All right. Should we stop the stream or just leave it going? I don't see a reason to keep it going.
I don't see a reason to keep it going either. But yeah, that's fair. Yeah.
Is there any like online people?
Well, that's true. Check if there's any online people. Otherwise, stop the stream and we'll re.
Is this the mouse for it?
That is the mouse for that. What is the pro? We can see your mouse. Oh, it's extended.
Oh, nice.
So
Got it.
I should explain the setup to you.